This is Heliox, where evidence meets empathy. Independent, moderated, timely, deep, gentle, clinical, global, and community conversations about things that matter. Breathe easy, we go deep and lightly surface the big ideas. Okay, I want to try a little thought experiment to kick things off today. If you can, assuming you're not driving, of course, I want you to close your eyes and just picture a drought. Really visualize it. What do you see? What are the colors, the textures?
I think I know where you're going with this. For most people, that image is pretty standard.
Right. It's cracked earth.
Withered corn stalks, maybe?
Yeah, or a reservoir that's just a big mud puddle with a bathtub ring around it.
Exactly. It's always hot. It's dusty.
It is. That's the Hollywood version of a water crisis. But what if I told you that one of the biggest threats to our water supply right now? It doesn't look like that at all. What if I told you it looked like a winter wonderland?
It's a really counterintuitive idea. We're sort of conditioned to think that water scarcity means heat. But the phenomenon we're unpacking today just completely flips that script.
We are talking about a drought that can happen when you are literally standing knee-deep in snow. It's cold, it's white, and to the naked eye, everything looks fine.
And that is exactly what makes it so dangerous. We're talking about a concept that researchers have started calling a creeping snow drought.
Creeping snow drought. I mean, it sounds like the title of a slow burn horror movie. And honestly, after reading the material you sent over, the reality is maybe even scarier.
It's definitely something that keeps hydrologists up at night.
So let's set the stage for everyone. We are doing a deep dive into a brand new study published just last month. That's January 2026 in the journal Communications, Earth and Environment.
Yeah, this isn't just a blog post. This is serious peer-reviewed science. The paper is titled Creeping Snow Drought Threatens Canada's Water Supply.
And it's by a team of researchers, Robert Sarpong, Ali Nazemi, and Amir Agakuchak.
A really impressive collaboration. You've got people from Concordia University, UC Irvine, the United Nations University. It's a big deal.
It is. And what they found is this massive, massive paradox. It's a riddle that really forces you to rethink how we measure our resources.
It really does.
Because I spent a lot of time with the data in this paper, and I have to admit, I got stuck on the headline number for a while. They looked at data for all of Canada and Alaska over the last 2 decades.
That's right, from 2000 to 2019.
And if you just look at the total amount of water stored in the snowpack across that entire massive landmass, the amount of water actually increased.
Yeah, and not by a little. Significantly. It went from around 799 cubic kilometers in the first decade to over 1,200 in the second.
So let's just pause on that. We have more snow water. The continent technically is getting wetter. A casual observer would think, great news, problem solved.
And that is the trap. That is the mirage. Because, the title of the paper isn't Canada has plenty of water. It says the supply is threatened.
So that's the mystery we need to solve today. How can we have record amounts of snow water and a huge water security crisis at the exact same time?
Well, the answer is all in the nuance. It turns out it doesn't just matter how much snow falls. It's all about where it falls.
Fair.
And maybe most importantly, the quality of that snow.
So it's a classic case of quantity versus quality with a serious location problem thrown in.
Precisely. But before we even get to the crisis, we have to talk about how they figured this out.
Yeah.
Because measuring snow, it's not as simple as it sounds.
Right. Let's get into that. The measurement mission. Because I think most of us, myself included, assume someone just goes outside with a ruler and sticks it in a snowbank.
And historically, that's not too far off. That's how you measure snow depth. And it's fine if you just want to know if the ski hills are open. But for a hydrologist, someone who needs to know how much water is going to be in the river in July, depth is a terrible metric.
Because all snow is not created equal?
Bingo. Just think about the difference between that light, fluffy champagne powder,
the kind that just blows away,
and that heavy, wet, back-breaking, slushy snow. You could have 10 inches of powder and 10 inches of slush. Same depth. But the slush might hold 5 times as much actual water.
It's like trying to figure out how much money you have by just counting the number of bills in your wallet.
That's a perfect analogy. Do you have $21 bills or $2,000 bills?
Yeah.
You don't know until you check the denomination. Snow depth is just counting the bills.
So these researchers, Sarpong and his team, they decided to stop counting bills and start checking the value. And they used this metric called SWA.
Snow water availability.
SWA. It sounds technical, but the idea is simple, right? It's just asking, if we melted the snow right now, how much liquid water would we get?
Exactly. It's the actual water stored inside the snow.
Yeah.
But here's the kicker, and this is why the study is so groundbreaking. Measuring density and water content across a continent like North America, I mean, that's a logistical nightmare.
Yeah, how did they do that? The paper mentions gridded data sets. They didn't send 1,000 people out into the Yukon with buckets.
No, definitely not. You have to remember, huge parts of Canada and Alaska are just wild. There are no weather stations. It's millions of square miles of silence.
So they had to build a kind of digital reconstruction of the continent.
Essentially, yes. They used a grid system. Imagine laying a huge digital mesh over the map of Canada and Alaska, where every single square is 25 by 25 kilometers.
That is a lot of squares.
It is. And for each one of those squares, they pulled in data from multiple sources: satellite imagery, ground observations where they existed, and these really complex computer simulations of the atmosphere.
So they mashed all of that together to get a high-resolution map of the invisible water being stored across the entire North.
They created a truth detector for water. And once they had that map, that paradox we mentioned earlier started to make a whole lot more sense.
Which brings us to what you called the tale of two Canadas, because when they looked at where that SWA was actually increasing, it wasn't spread out evenly.
Not at all. Remember we said the total amount of water went up? Well, almost all of that increase happened way up north. The Arctic, the tundra.
Places where, practically speaking, almost nobody lives.
Right. So from a human resource perspective, it's like money in a locked bank account. We can't use it. You can't just pipe water from the Arctic Circle down to the cities.
So the savings account is getting bigger, but it's in a branch on another planet.
That's a great way to put it. Now look at the other side of the coin. While the Arctic was getting buried in snow, there was one specific region that was losing water fast.
The North American Cordillera.
The Western mountain ranges, the Rockies, the coast mountains, the whole spine of the continent.
Okay, let me play devil's advocate for a second here. The paper says that these big losses were only found in about 3% of the total land area. I read that and I thought, 3%? That sounds like a rounding error. Why does this tiny 3% matter so much?
It's a fair question because 3% sounds tiny. But in both real estate and hydrology, it is all about location, location, location. That 3% isn't just random land. That 3% is what we call the water towers of North America.
The headwaters.
Exactly. The tops of those mountains are where the great rivers begin. The Fraser, the Columbia, the Mackenzie River systems. They are the engine of the water cycle for the entire West.
So if the drought is happening there, it poisons the well for everyone downstream.
And the study has this one terrifying statistic to drive that home. That tiny 3% of land, those specific mountains, they supply water to regions where approximately 86% of Canada's population lives.
Wow. Okay. 86%? That puts the 3% in a totally different light.
Right.
We are talking about the water source for nearly 9 out of 10 people.
Yes. So the water is piling up in the Arctic where very few people need it, and it's vanishing from the exact peaks that feed the farms, the cities, and the industries.
It's a massive mismatch, a supply and demand problem driven by the climate.
It's the definition of a location problem.
And this gets us to the name of the phenomenon, creeping snow drought. I want to dig into that word, creeping. Why not sudden snow drought?
Because of how it behaves. Think about a regular drought, a rainfall drought. The rain stops, the grass turns brown. It's obvious, you know what's happening right away.
It's visible.
A snow drought is insidious. It hides in plain sight. You can look at the mountains in January and they look white. They look beautiful. The ski resorts are open. You think everything is fine.
But underneath the surface, the density of the snow is dropping.
Exactly. Or the snow line is just inching a little higher up the mountain each year. It happens slowly. It's cumulative. You don't notice it year to year until you cross a tipping point.
The paper talks about that, a tipping point, and uses some statistical terms like a p-value of less than 0.05. Without getting too into the weeds on stats, what does that actually mean?
Think of it like trying to tune an old radio. You have a lot of static. That's just normal weather. Some years are snowy, some are dry. That's noise. The researchers use that p-value to filter out all the noise to find the real signal.
So they were looking for places where the loss of snow wasn't just a bit of bad luck, but a consistent downward trend.
Exactly. When they say significant loss, they mean the signal is loud and clear. We've crossed a threshold where the system is fundamentally changing. And the driver is temperature.
Which brings us to the mechanism. It's not just about melting.
It's more fundamental than that. It's a shift in the fraction of precipitation. In simple terms, More of what falls from the sky is coming down as rain instead of snow.
Okay, but help me with the physics here. If it rains on the mountain, the water hits the ground. If it snows, the water hits the ground. It all ends up in the river, so why does it matter what form it's in?
It matters because of timing. This is the absolute crucial concept. Snow acts as a natural battery,
A battery.
a water battery. It falls in winter, it freezes, it sits there, it stores that water for months. And then, crucially, it releases it slowly in May, June, July.
Right when the sun is out and the farms and cities actually need it.
Precisely. Now, imagine that same precipitation falls as rain in January instead.
It doesn't stick around.
It runs off immediately. It can cause floods in the winter, and it flows right out to the ocean.
So you get a flood when you don't need the water.
And then come July, when everyone is desperate,
Mm-hmm.
the battery's empty.
Yeah.
The mountain is dry.
So creeping isn't just that the volume is declining. It's that our natural infrastructure, our storage tank, is springing a leak.
The reservoir's broken.
Yeah.
And that leads to the really big question, the so what? Why should someone sitting in, say, Toronto, care about the density of snow in the Rocky Mountains?
Well, the authors list a few reasons that are honestly pretty terrifying. Let's start with the big one for the economy. Power.
Hydropower. Canada is a hydro superpower. But those dams are all designed around one very specific assumption.
That the water is going to show up in spring and summer.
Right. They expect that battery to discharge slowly.
Yeah.
If all the water rushes down in January as rain, the dams often can't hold it. They have to spill it. That energy is just gone, wasted.
And then in August, when everyone turns on their air conditioning.
The flow in the river is too low to spin the turbines at full capacity. You end up with energy droughts. It's a huge vulnerability for a green energy grid. You can't have reliable hydro without reliable snow.
Okay, so that's the lights going out. Second impact, food.
Irrigated agriculture. Think about the southern prairies, the fruit valleys.
I've driven through there. It's incredibly productive land.
But a lot of that land is naturally semi-arid. It's only green because of irrigation. And that irrigation system is completely dependent on the timing of the snow melt.
So if the snow drought creeps in, that timing gets thrown off.
Completely. You create a disconnect between the water cycle and the growing cycle. You can have a year with average precipitation, but if it all came down in February, your crops could still fail in July.
And the third one, this feels the most visceral, especially with what we've seen on the news lately, wildfire.
This is a huge one. The study explicitly connects the loss of snowpack to how dry the soil gets in the summer.
That makes sense. If the snow melts 2 weeks early, the ground has 2 extra winds to dry out.
Exactly. A deep, dense snowpack is like a giant wet blanket on the landscape. It keeps the high country damp well into the summer. You take that away, and by August, the soil is parched. The forests are like tinder.
The paper even references the record-breaking 2023 wildfire season as an example of what these dry conditions lead to.
That was apocalyptic. The smoke from those fires reached Europe. That's what happens when the landscape is primed to burn. And a lack of persistent snowpack is a massive factor in that.
So it's all connected. The snow falls in the mountains, which keeps the forests wet, which feeds the rivers for the farms, which spins the turbines for the cities. If that critical 3% of the land stops doing its job,
the whole system starts to wobble. That's the threat. It's systemic.
You know, something else in the report really stood out to me. They noted that even in the areas outside the mountains, across southern Canada, they saw insignificant decreases.
Right.
Which implies that even where it's not a full-blown crisis yet, the trend is still pointing down. It really is creeping everywhere.
It is. And it highlights why this new metric, SWA, is so important. If we were just looking at snow depth, we would miss the signal entirely. We'd be flying blind until the reservoirs were already empty.
These researchers have basically given us a new dashboard, and it's flashing red in the mountains, even if the overall numbers look green because of what's happening in the Arctic.
It's a truth detector for water security. It forces us to ask the right question. Not, is there snow, but where is the water?
So what's the takeaway? What do we do with this? The study feels like a diagnosis that the patient is sick.
Well, awareness is the first step. For water managers, for city planners, this has to be a wake-up call. We have to start planning for a future where that natural battery is smaller and less reliable.
We can't just assume the mountains are going to hold on to that wealth for us.
No. It might mean we need to build more artificial storage or develop vastly more efficient irrigation or just rethink how we manage our hydro resources. We have to adapt to a water cycle that's faster and more volatile.
It's a heavy thought, but I guess that's the power of this kind of work. You take a PDF file full of charts and data and you realize It's actually a story about the future of how we all live.
It really is.
Yeah.
It turns a weather statistic into a question of our own resilience.
And before we wrap up, I just want to acknowledge the human element. The authors, Sarpong Nizami, Agakuchak. It takes years of work to crunch this much data.
Oh, it's monumental.
Mm.
They didn't just write some code. They made an invisible crisis visible.
And they did it to spot the pattern before it's too late? I mean, that's really the highest goal of science.
I couldn't agree more.
So here's my final thought for you, our listener. The next time you see snow, whether it's just a dusting on your car or a picture of a mountain online, try not to just see it as weather.
Don't just check if school is canceled.
Exactly. Look at it as a savings account.
Yeah.
And ask yourself, is that a dense, high-value deposit? Or is it just fluff? Because as we learned today, our whole way of life is built on the assumption that those mountains are holding that wealth for us. And if the bank is starting to fail,
We need to know about it. And we need to be ready to balance the budget ourselves.
that's a wrap on the creeping snow drought. A huge thank you to the researchers for their work, and thank you for taking the deep dive with us.
Stay curious, everyone.
See you next time.
Thanks for listening today. 4 recurring narratives underlie every episode: boundary dissolution, adaptive complexity, embodied knowledge, and quantum-like uncertainty. These aren't just philosophical musings, but frameworks for understanding our modern world. We hope you continue exploring our other podcasts, responding to the content, and checking out our related articles at helioxpodcast.substack.com.